So the next talk is from Applied Materials, India. Mr. Madhav, Mr. Prasad. Okay, Prasad. Yeah. Prasad will speak, and he'll tell us his last name. Come on over.
Thank you.
I keep mixing up Prasad and Madhav.
Oh, no problem. Okay.
Oh, you're putting on?
Scalability stuff and all. I think few of the things maybe I need to repeat. Okay, I'm from Applied Materials. I think most of you who doesn't know about Applied, so I want to give you some small introduction about Applied. So we are into the precision materials engineering, and which enables the semiconductor and the display fab equipment. So we are not actually, we are behind the scenes of Samsung's, LG, and Intel and all. So, and we are into this particular business for the past 50 years. Actually, we completed 50 years in 2017 as Applied Materials overall and globally. And in India, we are having a presence in Bangalore and few other locations, and we completed 15 years in India as Applied Materials. So to give you a overview of this particular Applied Materials, as I said, so we make the equipment for semi and display, and with the revenue numbers of 14.5 billion, so that is for our fiscal year 2017. And we are having a spending of R&D around more than 10% we spend on the R&D from our revenue. And our headquarters is in Silicon Valley, California, and globally we are having around 18,400 employees. And in India, I think Raj was mentioning about 2,000. Actually, the number has changed. It is now 3,000. Thank you. Yep. So this is Applied Materials in India. So 3,000. So we are into 4 different locations. And what we do is mainly the engineering and the R&D, which is required for the semiconductor industry as well as the display industry. So we are having our headquarters is in Bangalore, and we are having the sales office in New Delhi here. And we have a research and development lab in collaboration with IIT Mumbai in Mumbai. And also we have a software division in Chennai. So altogether, so we have basically, we are into different locations of India. And with Twin Star there, maybe I think we need to think of setting up something near to Nagapur. Okay, so as most of you said that, okay, so display in the morning and in the afternoon also, people, I think, pretty much told about the display, how it is and all. So what we say is the displays of the world for the information. It means if you want to see something, then you need to have the display. So whether it is a safety or education or entertainment or the social networking or the productivity or the health or fashion. So whatever may be the scenario of the end market, so you basically need the display, because that's where actually the human interaction will come, right? So that's why you say that, okay, this is the information window. Coming to, okay, I think we have talked about so much about the flat panel display stuff and all. So which country has come first as a flat panel display manufacturer? Any guesses? It's Japan. Yeah, but why Japan has evolved as the first one? Because it started with the passive LCDs and all, and the main thing is they already have the computers, and also they need the flat panel displays for their computers. So basically, this particular industry has grew because of the necessity that we say. And how this particular display has come is first the laptop PC display, and then monitor, and then the large screen and all. That we call it as the LCD era. And now I think people, most of you talked about the OLED era, so I don't want to repeat so much on that. Maybe I give you some glimpse of what is the OLED, but without any repetition. And as you know, the smartphones, AR, VR, and the foldable, bendable, rollable, all these displays, okay, we say that it is the OLED era. Maybe some people may say, okay, it may be quantum dots era or OLED era, we don't know, but it is basically the, okay, so we call it as the OLED era. And the next is the 3D display, so how actually we can make from the natural 3D stuff and all, right? So if you see the display technology roadmap, first actually it started with the resolution. So we are into the high definition resolution stuff and all. And if you see the TV market stuff, so we have a 4K, 8K. So basically it is going to the high PPI and all. And the next thing is the form factor. So that's where is very much important, where the OLED is playing a major role. So basically the foldable, rollable, and then bendable stuff and all. I think we already see the curved one, and I think we already will see the rollable and all. And in end of my presentation, I can give you something, the latest OLED technology, how actually we can make the foldable stuff and all. And size is also another important factor. So if you see earlier our TVs and phones and all, so it is basically the 40-inch and then 4-inch for the mobile stuff and all. I think now most of us are having more than 5.5-inch mobiles, as well as TVs. I think it is 55-inch, 70-inch, like that. The TV size is also pretty much increasing. And if you see the technology stuff and all, as all of you know, so we are having the TFT and the display both. And in the TFT, so either we can go with the amorphous silicon, so, and then that has converted into either LTPS, low temperature polysilicon, or the metal oxide stuff and all. And if you see the display side, that is where I think we can see the front plane. So in the front plane, we can say that from LCD, we are moving into the OLED, and then from rigid to the flexible, and from 2D to 3D. So if you see the transistor stuff and all, so it is basically, I have not envisioned so much of change. Basically, I think from amorphous silicon, we are going to the mainly the metal oxide stuff and all, and LTPS is also pretty much very much exists. But people are different, okay, whether to go with the LTPS or metal oxide. So still there is a huge debate. And the thing is, for all these particular displays and all, so display is what we see in the front plane, but in the back, actually the more computing has to happen. And most of you have seen, so how this particular, in one of the trade stores, we have already seen the car, how it looked like with the displays all around and all. And also the Hyundai Automotive, so the driving cars, they also pretty much displayed this particular dashboards where I think you can entirely see the display stuff. Okay, the next, so who is the second to make this particular, which country has come up? I say it is Korea. So with most of the Samsungs and LGs, I think they all jumped in. What exactly actually make them to come into this particular thing? I say plenty of money and willpower. So that's what I think making them to come as a second to make this one. And also one more thing is the chip and the computer products business is already existing there. So that actually acted a catalyst to make this particular thing as come up with the large flat panel display manufacturer and all. And also, so they have so many sales channels and already the brands which are available, Samsung, LG, so they are already the brands. So because of that, I feel that, okay, it is pretty much easy for them to penetrate into this particular flat panel display business. Okay, I think this is something which Dr. Song, I think he said, okay, how this particular generation glass stuff and all, which has come up from generation 1 to generation 10 stuff and all. Right? So if you see the wafer, so now I think it has moved from 200 millimeters to the 300 millimeters, and the glass is almost the Gen 10 glass and all. So this particular Gen 10 glass systems, I started working more than a decade back when Sharp has first come up with a first Gen 10 fab for the TVs and all. Sakai. Yeah, Sakai. Okay, for that one, the first test stand, that was my first project to work on, so it was pretty much successful. We could able to ship the first Gen 10 fab to Sharp. And now I think there are so many other players are now coming up with the Gen 10 fabs and all, right? So what we can say is, okay, the main thing is how we can handle this particular thin glass and all. Earlier, the glass size was around 0.7 millimeter stuff and all. I think now, I think my colleagues have said, okay, the thickness of this glass is coming down, further down. I think now it is coming to 0.3 millimeter and all. And if you really need to have a AR, VR stuff and all, I think it is further come down to 0.1 millimeter thin glass and all. I have seen in one of the trade show a 0.1 mm thin glass AR, VR device, yeah. So I think this is a kind of a repetition kind of a slide when you call with the OLED LCD stuff and all. So let us see the LCD. So we have the backlight unit, and then we have the TFT black plane, and we have the liquid crystal, and the color filter, and the polarizer, so that you can really see how the LCD stuff and all. So in other words, how I can say is this everything is removed now. So all the backlight, whatever is required, so now we remove. So then what is happening is we come up with this particular OLED self-emission So that is basically removing all the things which are required for this particular backlight, and also it is removing your color filter, so that the number of component, number of processors have increased, but the thing is the things are becoming very thin and thin. So everything is come into the OLED liquid crystal emitter. So what are the key changes if you see in the technology for the flexible displays? So if you see, the main thing is the challenge is the flexible window, that is, and let us come from the flexible TFT we need first, the backplane, and after that, so we need to have the flexible OLED emitter we need, and again, so we need the flexible encapsulation, and then flexible touch sensor, and then flexible window. So all these things, if we can make it flexible, then I think we really have a foldable, bendable kind of a display. So these are the main challenges. So earlier we were having the transistor with the substrate, and also it is a easy structure if you wise, but the challenges, if you see, everything we need to make it flexible. So this is something, so if you see how the flexible display glass look like, so you can always see, of course there is no sound, but you can see how you can bend it, fold it, display using a OLED. Next, okay, the third country which came with the flat panel display stuff. It's Taiwan. Yeah, because the thing is, Taiwan, the main advantage what they were having is they have the strong laptop manufacturers which are already existing there, and also they have so many of the OEMs which are pretty much dealing with this flat panel display components that already exist. That actually made them to come pretty fast into this particular flat panel display business. Okay, so let us go into the TVs, because the most of the people covered with the mobile stuff, and also I want to go with a little bit on the TV stuff. So how actually the conversion from the CRT, I think the CRT era is almost gone. Now it is LCD, now then the OLED. I think you know the plasma thing, I think it has almost killed, right? So again, so there is a huge debate which is happening. So white OLED or the RGB OLED stuff and all. So there are again the key challenges. So if you go with the white OLED stuff and all, so you need to have the metal oxide stability, and then you need to have the efficiency and the lifetime. So these are the main challenges which you could able to see it. So if you want to have it, then okay, your TFT is a metal oxide TFT, and then your white OLED. Of course, if it is a white OLED, again, so you need another color filter for that particular thing. So if you go with the RGB OLED, so it is again the metal oxide TFT only, but the main advantage here is, okay, you can no need to have any color filter device, so because you already have the RGB stuff and all, self-emitting stuff. And next, so how actually the TV size growth is happening and all. So the TV, if you see, the size growth is enormous, because earlier, so we were pretty much, we always see in India around 22-inch TVs or 21-inch TV stuff and all. But now most of the stuff is going to 32-inch. And if you see the trend, I think by 2020, and the average TV size is going to more than 40-inch stuff and all. So that's where I think it is more demand is coming up. And the size increase is pretty much continuous year over year. Next. Yes, you're right. So it is China. So, okay. China don't have the established business for the selling. Okay, the thing is, the China advantage is, if you see, they surpassed, I can say, the Korea and the leading supplier for the display, because I think you see so many fabs are coming in China stuff and all. But what they concentrated, we feel is they are making the low-end displays, started with a simple display stuff and all for the domestic consumption. I think now things are going for the export stuff and all. Next. Yeah, it is India. That's why we are all here, so to make in India, right? Okay. Now I will go through, okay, so what are the things which we have to make this particular thing available? How we can leverage India? So the first thing I can say is the skilled talent. And it is pretty much the sustainable sourcing of this particular talent is exist year over year and all. And also we have a huge market. The market is growing like anything, right, in India. So you have a huge market. And also we have some enabling policies, I think in the morning. So we have talks from the government on this particular thing. So what are the policies they come up with this to actually accelerate this particular electronics manufacturing in India. So if you see the talent pool where it exists and all, so from 1980 to 2010, so if you see the non-farm jobs and all, and we have 245 million college graduates added globally for the labor stuff and all, and we have 75 million young workers which are there. But if you move from 2010 to 2030, then I think the numbers have pretty much increased, and most of the things, the 60% of the share comes from India, South Asia, and the Africa. So that's where actually the talent pool is coming up, right? So it is just to give some. And the talent, okay, it is not so cheap in India, right? These are the Indians, okay, I think you all know. So sometimes the talent from India is not that low cost. Because we have Satyanarayana, and okay, the talent, I think there is no doubt the talent exists in India, so they can run global as well as from the India stuff. Coming to the market, so it is the fifth largest consumer durable market we have. So if you see from FY15 to FY20, the average growth rate is 10.5%. And the TV, the third largest TV industry, so again, the growth rate is more than 15%. And the fastest growing thing is the electronics market, I can say. So it is 22% growth we always see in this particular electronics market. TV set demand. So this is something to give you the factors for India. If you see earlier in the TV demand slides, I think I never saw India picture. So it is always embedded into the Asia Pacific stuff and all. So this is something I think we could able to make. So how actually the India demand in the TV sets and all. So here you can see the demand is, it is growing pretty slowly, but I think by 2020 you can say is around 20% of the global TV sets are required for the India region. And coming to the policy stuff and all, so we have already seen the Make in India policy, so which basically to enable the semiconductor fabs and the display fabs in India, and also the electronics, that is the MSIPs, we all know. This is also another. So there are enabling policies which we have to actually encourage the electronics market development as well as the manufacturing of this particular electronics manufacturing in India. So I think we have talent, we have market, and we have the policies. All three exist. So what we need, basically what we feel is we have the unique opportunity to leapfrog this particular things into the fabs. And what we feel is first thing is the money and the willpower and the ecosystem. So these are the three things which I think we need to have, because the main things what we need is the talent exists, market exists. So now, so we need to see the willpower. So that's where actually it will make our dreams true to come into this particular electronics manufacturing in India and grow it further and further. And also the India has a very good advantage because we need to really see that, because we already seen the technology trend how it is. That means we know which technology is actually the winner. Of course, so we are not going to the OLED or the QLED stuff, but for the amorphous silicon stuff, and also we know what are the technologies which are exist, okay, whether we need to go with the 4-mask or a 5-mask process stuff and all. So we have many data, because we already know a few people, okay, how they grow and what technology is growing and all. So in that way, we have a pretty much advantage. And also we know that, okay, what is the next technology which is coming. That means we can think of what the upgradability we need to have it. So that means whatever the equipment which we see, for example, the amorphous silicon, if you go, then always we need to think, okay, can I convert this particular amorphous silicon fab to a metal oxide stuff? So that we can think now itself. So that is another advantage which we have in India. And also the thing is the beyond hardware, so we need to think, so what are the other things which can grow further from design of this flat panel displays into the systems. So we can think a little bit more, maybe the e-ink stuff and all. So this is something, the next end stuff and all, right? So that is another advantage which I could see in India, so to promote this particular display fabs. And finally, what I can say is it is possible to make it in India. Yeah, thank you. Yeah. Sorry, I will remove.